Hello everyone and welcome to a video on polymerase chain reaction. PCR is a method at which we can actually make more DNA from DNA. Now this method is essentially a way that we can mimic DNA replication without the use of the majority of the enzymes that are normally found in DNA replication. This method uses thermal stable DNA polymerase, uses forward and reverse primers, and lastly, we'll be using a temperature gradient. We're going to be changing the temperature in order to be able to accomplish this. Let's first look at the overview. When we look at this process, we see that over time, one cycle of PCR, essentially one round of this replication, is going to be going through three main different phases, three main different temperatures. You're going to notice we're starting off really, really hot. We're going to start decreasing that temperature to the lowest temperature it'll hit, and then eventually we'll increase it just slightly in between these two temperatures, and we'll leave it there before we restart. We can separate our phases into three different subcategories. This is going to be our denaturation phase, this is going to be our annealing phase, and our extension phase. In the denaturation phase, what we're doing is we're increasing the temperature high enough so that we can actually separate our strands of DNA. Now, normally in DNA replication, we'd be using something like helicase to do this process. However, since we don't want to incorporate all these different enzymes, what we're going to do is use temperature to break the hydrogen bonds and thus separate these strands along the hydrogen bonds. Now, this is accomplished usually by increasing the temperature to about 94 to 98 degrees Celsius. You'll see that there is a range of temperatures for every single one of these phases. It's not exact and it depends on the specific DNA molecule you'll be working with. The next phase is annealing. Now this uses that denatured DNA that we just made, and we actually incorporate something called forward and reverse primers. Think of this as being like what normally would have been made by primase. Now these primers are then going to bind to our fragments of denatured DNA at 50 to 70 degrees Celsius. Again, this is dependent on the specific DNA we're working with. Now, this decrease in temperature essentially allows for hydrogen bonds to form. Once these hydrogen bonds form and our primer finally binds to our single-stranded segments of DNA, we're ready for the next step. In this last step, we have extension. This is essentially polymerization. This is now we have our DNA, we have our primers on there. The last thing we need to do is make sure we have our DNA polymerase. This step happens at around 72 degrees, somewhere between 70 and 75. And this is essentially just incorporating this DNA polymerase to make sure that every single one of the extra nucleotides after the primers get added. And like this, now suddenly we started with one molecule of DNA, and we've just finished with this whole process of PCR making 2 molecules of DNA. I hope this helps.